So at the end of my y min, I'm going to change it from negative 100. I'm going to add a 0 there, so it's going to be a negative 1,000. So change your window for your y min and your y max. And at the same time, I also change the scale. So I'm going to change that to a scale of 100. So that avoids that problem of having so many increments on the y-axis that it looks like a solid, thick line. There it is.
Mine did that.
Great.
That means wrong.
You did it. Good job. So as you can see, it hits the x-axis 3 times. So that's actually the solution to this question. How many points of intersection? If you can persevere and figure out the window that you need, we decided on this window, and you make sure and carefully enter it in exactly as the question says, this is a lot easier than actually going through and setting each one of these equal to 0 and solving. Would you agree?
Mine looks like this though.
Yours is just stretched out a little bit more because
Okay, because you said it hits like 3 times, so it just had to be
yours does. Yours hits the x-axis 3 times.
1, 2. Okay.
Yep. So yours, it looks like you could go down further on the y-axis. So your window, you might want to go ahead and change the y minimum, make your y minimum a little bit lower than whatever it is right now. What's your y minimum? Well, I'll look at yours in just a second, okay? So the answer to this is 3 points of intersection. Yesterday in the notes, you saw me identify what my leading term of my polynomial would be just by looking at the first term in each group, in each of my factors, and multiplying those together. So I'm going to do x squared times x cubed. So write this down. Rather than foiling the whole thing out, we're just going to look at that first term in our polynomial, multiply these out, we add the exponents, so it's going to be x to the 7th, 2 plus 2 plus 3. Given our previous instruction, in example 1, we know that there should then be 7 total solutions. However, we only saw this graph hit the x-axis 3 times, right? It went like this. That's what I went to college for. So, where are the other 4 solutions? I'll tell you. Looks great. You see, there's different types of roots. We call this the nature of the roots. So there are 2 types of roots for any polynomial function. We have real solutions, and then we have imaginary solutions.
Yeah, I know those words.
Awesome. Nothing new to see here. So you see in this first graph, according to the degree of my polynomial, I should have 4. So degree 4 should indicate 4 total solutions. When I look at my graph, I can find my real solutions by seeing how many times it hits the x-axis. So there's actually just 2 real solutions. So that means there would then be 2 imaginary solutions.
Wait, how did you know which one was real and which one was imaginary?
I started by figuring out the degree of my polynomial and realizing that meant that I had 4 total solutions. Then I looked at the graph. Based on the graph, I have 2 intersections with the x-axis. The number of intersections is what correlates to the number of real solutions. So 2 intersections means 2 real solutions, and then the other 2 are imaginary.
Because they're not like exactly on a point or something. 'Cause I can see like the 2 real.
Yep.
and
There's
the two-
only 2 times that this graph actually hits the x-axis.
Oh, okay.
Yep.
And the
The-
imaginary would be the y-axis.
No, the imaginary are just solutions that
Don't hit the.
don't hit the x-axis.
Okay.
Okay, so then this one, degree 3, indicates I have 3 total solutions. You can see again, it hits the x-axis in just one spot, which means I have what? How many real solutions? 1. How many imaginary?
2.
Good.